If you then look at applying that last chart to OCTG steels and line pipe steels, well, take a pure iron product, and we've got the same kind of stress-strain behaviour. If you have a pure iron product, it's not very strong, but it's actually very malleable, very ductile. There's very little in a pure iron product other than iron, not surprisingly. There's pure iron, there's no carbon, so it's a very soft matrix. It's very, very bendy. You can't really use it very much. It's actually quite hard to make because most commercial processes will introduce some impurities, usually carbon, sometimes other things. As you move up, wrought iron, not sort of used commercially very much these days, there are more impurities. Mild steel has more of a profile where there's now a steeper part to the stress-strain curve, so the elastic part is reduced, but the steel is much stronger. Then there is still a plastic limit, and finally the steel will break. And a high-carbon steel, the carbon is acting as a strengthener. It's increasing the strength in the matrix and the microstructure, what the steel looks like. And these pictures are steel magnified probably in the region of about 100, 150 times. This is actually what steel will look like down a microscope. So in the soft steel here, you've got essentially pure iron, grains of pure iron, very little else there. In the mild steel, this is what's called a pearlite microstructure. This is a combination of ferrite and cementite, Fe3C iron carbide. There's the carbon is there combined as iron carbide. This is a much stronger microstructure. And then in the high carbon steel, we have a different microstructure. This is called martensite. In fact, this is a tempered martensite. It's been heat treated, just to give you an idea of what the steels look like.